Hello, everyone. My name is Homoto, and I'll be your maths tutor for today. Today's topic is linear function. Okay. So, firstly, we would like to know what a linear function is. A linear function. Linear functions are the workhorses of many mathematical applications. They describe the straight line relationship between an input x and an output y. So let's dive into their world. The equation behind the line. So we have the equation of the line. The equation that defines a linear function. This is a linear function. So a linear function is a function of this line, a straight line. Okay? It can be like this, it can be like this, or like this. Okay? So what is let's quickly describe this. Y is equals to mx plus b. What is that? M is what we call the slope of the line. Okay. M is this is the slope which tells you the direction and the steepness of the line. So we have positive M and negative M. The line slants upwards as the x increases. Slants like this. This is a positive one, and we have the negative slope. The line slants downwards as the x increases. It's like this. Just like this. So this one, as x increases, the line slants up. And this one, as x increases, this thing slants down. M is equals to 0. The line is horizontal. So when the line is like this, when m is equals to 0, meaning the line is just horizontal like this, there is no slope here. So no change in y with the change in x. We have b. This is the y-intercept, which is the point where the line crosses the x. The line crosses the y-axis. So let's say we have a Cartesian plane like this. So B will be this point here, the point where the y-axis, where this line intersects the y-axis. So we have examples and visualizing with the graphs. We have example will be y is equals to 2x plus 3. So firstly, put it in this format. What is m? M is 2. What is b? B is 3. Okay, meaning the line has a slope of 2, meaning it increases by 2 for every 1 unit increase in x. Okay, so if we were to draw it, it will be like this. So let's say 1, 2, 3. This is 3. And then it cuts the 3 there. Okay. So we know our line cuts the 3 there. And then it has a slope of 2. It has a slope of 2. Remember, there's a formula for slope which says y2 minus y1 over x2 minus x1. Okay? So what does it mean by them saying it increases by 2 for every 1 unit increase in x? So it increases by 2 for every 1 unit. Okay? So now our line would be something like this. It has to intersect the 3. So it has to intersect the 3. Since our slope is positive, meaning it's an increasing one, like that. So the line crosses the y-intercept is 3. So the line crosses the y-intercept at 0 and 3. Okay. When we're graphing it, plot the y-intercept 0 and 3 and use the slope to move from there. Since m is 2, move up 2 units and right 1 unit. This gives you another point on the line. So you have to connect these 2 points to get the straight line. So let's do that. I was just estimating how the line is going to be. Now let's find the precise line. This was just my estimation. Okay. So when you have this, we know y is equals to 0 and 3. Okay. So we want to know, let's say we want to know where the x-intercept of this line would be. We know the y-intercept is 3. It's 0 and 3. But then what is the x-intercept? So we put y0 and then we say 2x plus 3. And then we then put -3, 2x, and then x would be -3, which is 1.5. Negative 1.5. So we have x as negative 1.5. Now let's draw the graph. So meaning this line intersects the x at negative 1.5 and it intersects the y at 3. So let's say that here is 1 and here it's 1.5. Here it's 2. Here is 3. Here is 1. Here is 2. Here is 3. So meaning 1.5 is going to be somewhere here. Let's make a point there in this color. So this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So it cuts here and it also cuts there. So let's make a line. So this is how our line is going to be. This line is called y is equals to 2x plus 3. Now let's move to the next thing. We have the key features of the linear function. It has a constant rate of change. Okay. It has a constant rate of change. The slope m represents the constant change in y for every 1 unit change in x. So the slope m, it represents the constant change in y for every 1 unit change in x. We have infinite line. Infinite line, what does it mean? The line keeps on continuing. It doesn't stop. Of course, when we write it, when we draw it, it's just gonna be like this. But then in reality, this line goes up and goes down. It doesn't stop it, so it continues. It's infinite. So it's infinite. A linear function extends infinitely in both directions, both positive and the negative. Okay. Domain and range. The domain is all the possible x values. It is usually all real numbers, and the range will be all possible y values and depends on the slope and the y-intercept. Working with linear function examples. Let's say finding the slope given the equation. This is the equation. What's the slope? The slope is -3. So the line slants downwards. On our Cartesian plane, this is how our graph looks like. This one has a negative. It has a negative slope. So it has a negative slope. Okay. Equations from 2 points. You are given this point and this point. They say find the slope and equation of the line. Okay. So remember, slope is given by m is equals to y2 minus y1 all over x2 minus x1. Where does y2 you put? Let's say this is 0.1 and this is 0.2. You can choose your points. Okay. Where does y2 we put the 3, and then where does y1 we put 1. And where does x2 we put the -2, and then where does x1 we put the 4. Okay. Sorry. y2 minus y1 over x2 minus x1. So where there's y, you put -2, and then you put -1. Where there's x, you put 3, and you put 1. The up one becomes -3, and this one becomes 2. Yes. So this is 4, pardon me. So -6 over 2, it becomes -3. So as you can see here, they said m is equals to y2 over x2 minus x1. Therefore, you put -2 there. From here, you divide 3 minus 1, and then when you do your calculation, you will find that m is equals to -3. Then use the point slope to find the equation y minus 4 is equals to -3 x minus 1. What is the point slope? Point slope says y1 minus y. So it's y1 minus y is equals to m x1 minus x. Okay? And then you leave the other one as it is. This one you choose the point. So it's firstly, let's see that we have y1 minus 4 is equals to m. We found it from the previous calculation, which is -3. We have x1 minus x. Okay? We do not substitute anything for these ones because we are looking for the equation. Okay? So we have y1 minus 4 is equals to -3, x1 minus 1. And then from here, you can do your algebra. You have y1 minus 4 is equals to -3x plus 3. And then you have y is equals to -3x plus 7. That is the answer. -3 plus 7. So that is the answer. That is the equation of those lines in 2 points. Application. A company charges $10 per car wash plus $15 fixed fee for cleaning supplies. The total cost is C. The function relating cost C to the number of cars washed X is C is equals to 10x plus 5. This is a linear function with the slope of 10 representing the cost per each car. We have things to remember. Linear functions are building blocks for many mathematical models. Understanding slopes and y-intercepts is crucial for working with the linear functions. They can be used to represent real-life proportional relationship. By practicing with this concept, you will master the art of linear functions and unlock their problem-solving power. Worked examples, okay? Finding slope and y-intercept. The equation of linear function is given by that y is equals to negative 4x plus 2. Find the slope m and the intercept b. So the slope is this one, the intercept is 1. So the slope is negative 4 and the intercept is 2. This means that the line slant downwards because it has a negative coefficient. Y-intercept is b, which is 2. The line intersects the y-axis at 0, 2. Equation from a graph. The graph of a linear function shows it passes point 2.5 and negative 1.1. Find the equation. So we use this one. Y is minus y1 is equals to mx minus x1. Pick one point, let's say 2.5. You can choose any point that you want, okay? You can choose negative 1.1 as well. Pick one point, 2, 2 and 5. And then you take this thing, you substitute it on this equation. Okay, how do we do that? You say y1 is equals to 5, and then our x1 is equals to 2. Let the other point be x and y. We don't substitute anything for this x and y. Since we don't know the slope m, we need to find it first. So we use the equation of the slope, which says y2 minus y1 over x2 minus x1. Okay? So, what is the slope? Given the 2 points, 2, 2 and 5, and negative 1 and 1, we can just simply find the slope. So, we have 2 and 5, negative 1 and 1. So what is y? This is our y. Y, 1 minus 5, and negative 1 minus 2, which becomes 1 minus 5 is 4. Negative 1 minus 2 is negative 3. So this is our slope, okay? And then we go back to this one. So we say 1 minus 5. Is it 5? Yes, it's 5. Is equals to 4 over 3 x minus 2. And then we now have y is equals to negative 4 over 3x plus 8 over 3 plus 5, which becomes 4 over 3x plus, you add those together. When you add them together, you get okay, plus 23 over 3. So that will be our equation. Let's proceed. Application, the cost function. A bakery charges $2 for each cupcake and has $10 setup free to prepare the batter. So the total cost is C. Write a function to represent the cost C depending on the number of cakes bought. So the number of cakes bought is X. This describes a linear relationship between cost and cupcakes. The cost increases by $2 for every cupcake bought. So the slope is 2. So it's a constant increase of $2. The setup fee adds a constant cost of $10 regardless of the number of cakes. So the y-intercept is going to be 10. So the function is going to be cost is equal to 2 times x plus 10. It's a constant, and this one is the number of, for every cupcake you buy, you have to multiply by 2. Comparing lines, parallel versus perpendicular. We have two lines, y is equal to 3x plus 1 and y is equal to negative 2x plus 3. By comparing the slopes, the first function has slope of 3, okay? The second function has the slope of 2, of negative 2, okay? Since the slope are not the same nor negative reciprocal of each other, the lines are neither parallel nor perpendicular. So when the lines are parallel, the slope, when you multiply them, they have to give you 1. And then when the lines are perpendicular, the slope, when you multiply them, they have to give you negative 1. Pardon me. So the slope of the perpendicular lines, when you multiply them, they have to give you negative 1. And the slope of the parallel lines are equal. So if there's a parallel line like that, and these two are parallel, so the slope of these ones are what? They are equal. And then the slope of this and the slope of this, the slope of this one and the slope of this one, when you multiply them, they give you negative 1. We have what we call break-even point. So a lemonade stands in $3 profit from each cup of lemonade sold. So the revenue is R. And then they incurs a weekly cost of $20 for the ingredients. Find the number of lemonade sold at which the revenue equals the cost. So profit equals expense. This is what you call break-even point, where the profit equals the expense. So set the revenue function as R is equals to 3x equals to the cost, which is 20 plus 0x, since the cost is constant. Solve the equation. 3x is equals to 20 plus 0x, which gives you x is equals to 20 over 3. So the income is equals to expense. So if we were to draw it, this will be our first line. Let's say that's income. And then this will be our expense. This is our expense. So this one is expense, and this one is income. Income equals to expense. So let's say at this point is 20 over 3. The x is 20 over 3. Okay? So the break-even point is 20 over 3 cups of lemonade.